All right, grade 11's last day of rational variable expressions, other than your review. We're going to do addition and subtraction of RVEs and subtraction of RVEs. First of all, we're going to just look at plain old everyday fractions because the rules are all the same. If you have 2/7 plus 4/5, we know we can't add things that are different sizes. So we would have to change the size to be the same. So I am looking for a common denominator for 7 and 5. I would go for 30/5. That means for the first fraction, I have multiplied the top and the bottom by 5. So that I haven't changed the size of the fraction, just the look. So 10/35 is the same as 2/7. For the second fraction, I have multiplied top and bottom by 7. So I have 28/35 is an equivalent fraction to 4/5. But now they're all, I was going to say cut up because I'm used to talking about pizza slices. So now our fractions have equivalent sizes. We can add them. I have 38/35. So the key here is first finding a common denominator, and then we adjusted the numerators to match our new denominator. Second example, 6/11 take away 3/4. The process is the same. We can't subtract fractions that are different sizes. 11ths and 4ths would not be the same size. So we are changing to common denominator, which would be 44ths. In both cases, we have found the common denominator by multiplying the two original denominators. Sometimes you can find a smaller denominator that would be common to both. For the first one, we have taken our 11 and multiplied it by 4 to get 44ths. So we do the same to the top, 24. 24 44ths. Quarters, I would multiply top and bottom by 11, 33. When I subtract 44ths, I get 44ths. I have 24 of them, subtract 33 of them. I have negative 9 44ths. The key to solving fraction problems is to find common denominator. And implied in that is that you're going to adjust the numerator to match. All right, we've done it with just numbers. Let's do it with some rational variable expressions. We have 5x over 2y plus 10x over y squared. They have different denominators, so we cannot add them as they are. We need a common denominator. Our common denominator needs to include all of the bits from the first and from the second. I'm going to just reduce that, sorry. Okay. So this is my goal. Same for both of them. I need to make sure I've included a 2 because there's a 2 here, even though there's not here. My common denominator has to include a 2. I have a y in the first one and a y squared in the second one. So my common denominator would have to be a y squared so that both old denominators would fit into the new denominator. So my common denominator is 2y squared. I have to adjust the numerator to match. So for the first rational variable expression, I had 2y. My new denominator is 2y squared, which is increased by a factor of y. So I would have to multiply this top by a y. That fraction, rational variable expression, is the same as the one I started with. It just has y's introduced top and bottom. The second RVE is 10x over y squared, and the only thing that's different from the old denominator to the new is the number 2. So I would multiply top and bottom by the number 2. I have 20x. Now that I have a common denominator, I can add them. If you are adding 2y squareds, you get 2y squareds. We're adding 5xy plus 20x. They're different, so I have to leave them separate. There we are. There's our new answer. But since I am dealing with rational variable expressions, I need to write any restrictions. I have had y's consistently on the bottom all the way through the process, so my only restriction will be y cannot be 0. Second one, 3 over x squared minus 4, take away 5 over x plus 2. First of all, I am not sure what my common denominator would be because I've got some adding and subtracting going on. So it is much easier to see what your common denominator would be if you were to factor everything. X plus 2, x minus 2, because that's a difference of squares. This one is x plus 2, 3, and 5. Now that I have it written with all my factors obvious, then I know that both old denominators have x plus 2 as a factor. That means my common denominator is going to have an x plus 2 for sure. The first one has an x minus 2 as well. And even though the second one doesn't, I need to include the factor x minus 2. That is my common denominator. The first one hasn't changed. I still have a 3. But the second fraction had an x plus 2 as a factor. Now I've introduced x minus 2, so my new numerator has to be adjusted to match. If I am adding x plus 2 times x minus 2's, I get x, I don't know if you can make that a word, x plus 2, x minus 2's, I get x plus 2, x minus 2's. My numerator is 3, take away 5, x minus 2. By convention, we leave the bottom fully factored and tidy up the top as much as possible. Tidy the top. All right, 3 take away. I'm going to do the distributive law. 5x take away 5 times negative 2 is negative 10. That's the same as add 10. Okay. Lastly, I can put those together and get 13 minus 5x over x plus 2, x minus 2. I should state my restrictions. That means anywhere along the process, I can't have a 0 on the bottom. That means my common denominator has to include one of every factor that I've ever had. So your common denominator is a great place to look for restrictions. My restrictions would be x cannot be negative 2. That would give me a 0 in the first bracket. Nor can x be 2. That would give me a 0 in the second bracket. Final answer. C, x over x minus 1, take away 3x over x plus 2. There's no factoring that I can do. So I have a factor of x plus 2, x minus 1. So my common denominator would be x minus 1, x plus 2. I should write that out twice. X minus 1, x plus 2 is just going to be tight. X minus 1, x plus 2, and the second fraction would have the same common denominator. There. The first one used to have an x minus 1 on the bottom, and I've introduced a factor of x plus 2. So I have to adjust the top by the same. So it becomes x times x plus 2. There. That rational variable expression is used to my old, the same as my old first fraction. It just has a factor of x plus 2 introduced. The second one I have changed by a factor of x minus 1, so I have to introduce a factor of x minus 1 in the numerator. There. When I subtract x minus 1, x plus 2's, I get x minus 1, x plus 2's. All right. On the top, I have x times x plus 2, take away 3x times x minus 1. And by convention, we tidy that up and leave the bottom the way it is. Distributive law, twice, here and here, here and here. My new numerator becomes x squared plus 2x minus 3x squared plus 3x, a negative and a negative, right at the bottom. One more step for making it pretty. I've got x squareds and x's. I have 1x squared and negative 3x squared, negative 2x squared. I have 2x and 3x. I have 5x. There's my numerator, as tidy as it can get. By convention, we leave the bottom in factored form, and we state our restrictions. The restrictions come from that common denominator, so I'm looking at them right now. X minus 1 cannot be a 0. That means x cannot be the number 1. X plus 2 also cannot be 0, so x cannot be the number negative 2. I have two c's. Anyway, let's do d next. 8 minus 1 over 2x squared minus 2x plus 1 over 4x cubed. I want a common denominator that includes all of the factors. So I have a 2 here and a 4 here. So my greatest common factor has to include a 4. I have x squared and x cubed. So my my common denominator would be x cubed. So both of the old denominators will divide into my common denominator. For the first rational variable expression, I have 2x squared, and I have multiplied by a factor of 2x to get that common denominator, so I need to do the same to the top. 2x times the old top gives me my new numerator. The second rational variable expression already has the common denominator, so I don't need to change it. When you subtract 4x cubed, you get 4x cubed. And my top would be 2x times x minus 1, take away, bracket, because I'm going to take away all of that second numerator. And I need to be careful of my sign. Let's tidy up the top. Using the distributive law, I have 2x squared. Take away 2x. Be careful. Then I subtract each bit in the bracket. I will end up with negative 2x, negative 1. Last step of tidying is 2x squared minus 4x minus 1 over 4x cubed. My common denominator gives me my restrictions. I can never have a 0 on the bottom. That means that guy cannot be 0. There's my restrictions. Last question. E. Make him an E. 2 over x squared plus x over x squared minus 1. Because I see some subtraction and addition in the bottom, I don't have it in factored form. So I'm going to see if there's anything I can do. Otherwise, I'm going to have a nasty common denominator. So the first one, I see x squared plus x, and that has a common factor of x. When I factor out an x, I get x plus 1. Well, that's a little easier to work with. Plus x over, can I do anything with that denominator before I look for a common denominator? Yes, that is a difference of squares. X plus 1, x minus 1. So as I look for my common denominator, I'm going to make sure that I include at least one of every factor. So I need to have an x in my common denominator. I need to have at least one x plus 1. Well, there's one in this one and in that one, so that's common to both. So I only need one of them. If I had had x plus 1 squared, I would have needed 2 of them. But since I have an x plus 1 only in both, degree 1, then I only need degree 1 in the common denominator. And now I've made a mess. Last, I have an x minus 1 in only one of them, but still, I need to include it in my common denominator. There is my common denominator. Both of the other two denominators will divide into it. That means I can use that as a common denominator and adjust the numerators to match. So the first one used to have those two, missing x minus 1. So I'm going to adjust the top also by x minus 1. And I have a new version of the old rational variable expression using the common denominator. The second rational variable expression had one of these and one of those. So the only thing missing is the x. So I need to adjust the old numerator by x. It becomes x squared. My common denominator is x, x plus 1, x minus 1, and the numerator becomes 2 times x minus 1, add, this got messed up here, there we go, add x squared. Now I'm going to tidy up the top. Distributive law gives me 2x minus 2 plus x squared. Nothing I can do with that to simplify it. I can't put any of those terms together. And I'm going to leave the bottom in fully factored form. That common denominator also tells me my restrictions. I have 3 possible restrictions. X cannot be 0, or minus 1, or positive 1. Try some in your textbook. Same rules as adding and subtracting fractions. You just need to be careful. Page 128, 3 to 12.